Today we're going to learn how to graph rational function with horizontal asymptote. What you know about asymptote, you know one type of it, the vertical asymptote, right? The vertical asymptote, what does it mean to have vertical asymptote in the graph? Can graph cross the vertical asymptote? No, right? Graph never cross the vertical asymptote. So here, if you look at 1a, they say find the equation of the asymptote. Either you can eyeball the graph or you can look at the function. The function say there's x plus 4 and x minus 6 in the bottom. So that means I cannot take what? I cannot take negative 4 or positive 6. Right? So that will be your horizontal asymptote. All you set them equal to 0. Take a look at the factor in the denominator, which is x plus 4, and then x minus 6. And then you set them equal to 0, and then you solve. That will be your horizontal, vertical asymptote. One characteristic about vertical asymptote that the graph never crosses it, ever. This is the vertical line. Graph never cross. Try. Let's talk about the behavior near the vertical asymptote. Let's go from left to right. As x approaches negative 4 from the left. When I say negative 4 from the left, meaning I go very, very close to negative 4, but never reach negative 4, right? When x approaches negative 4 from the left, what happened to the function? It dropped, right? It dropped to infinity. So I write as x approaches negative 4 from the left. That's how I denote negative 4 from the left. This is negative 4. This is not the negative. This is from the left. Yeah, I suggest. Otherwise, you keep saying from the left. Mathematicians, they're lazy. They love simple. All right, and then y drop to negative infinity. What about when x approaches negative 4 from the right? And I would write like this, negative 4, and then a little plus to the upper right corner. Try to make the plus a little upper right. Don't write it like down there. It just doesn't look right. Then what happened to y? Yeah, it shoot up to infinity, right? So as x approaches negative 4 from the right, y shoot up to positive infinity. And then you do the same thing for 6 from the left and from the right. As x approaches 6 from the left, right like that, y go to negative infinity, x approaches 6 from the right, y go to positive infinity. So that's the characteristic of vertical asymptote. The function go to infinity, either positive or negative, around the vertical asymptote. What about horizontal asymptote? Let's talk about horizontal asymptote. Let's talk what happened to y as x increasing without bound. When I say without bound, meaning they go to infinity. Right? Let's take a look at the left, the function all the way to the left. when x approaches negative infinity, what happened to y? When x go to negative infinity, when the input go to negative infinity, what happened to the function? What the height? Where does it go to? No? When x approaches negative infinity, maybe I'll pull down so I can, when x approaches negative infinity, if I stretch my graph out to negative infinity, what happened to the graph? What is the height goes? Does it get close to what? Close to the x-axis, right? It's never quite reach it though, but it get close to it, right? So when x approaches negative infinity, meaning it's decreasing without bound. When x approaches negative infinity, it's the same thing as say it's decreasing without bound. Highlight that. Same thing as saying it's decreasing without bound. Then y approaches to 0. I say approaches to 0. I don't mean it's equal to 0. Okay. What about when x approaches positive infinity? When it's increasing without bound? The function goes the same, right? From 12 there, you go all the way to infinity. My function is look like it's kind of squashed down to 0, right? When x approaches to positive infinity, y, oh sorry, I wrote in the wrong place. Y also go to infinity. Move it down here. And again, x approaching infinity is same thing as x increasing without bound. So what does it tell you? It tells you that this behavior, when x increasing or decreasing without bound, y approaches 0. And this behavior create the horizontal asymptote. So we conclude that because it's approaching the same thing, we conclude that the horizontal asymptote is y equals 0. So the difference between horizontal asymptote and vertical asymptote, the first thing is that the horizontal asymptote approach to a number, right? When x decreasing or increasing without bound, right? Where vertical asymptote is what? When you get close to a certain value, the height going crazy, right? Either shoot up to infinity or drop down to negative infinity. So that's the difference. Another difference is that the graph never cross vertical asymptote, but the graph may or may not cross the horizontal asymptote. And then I'll show you how to find when it's the cross. So let me do a little note there. Graph may or may not cross the horizontal asymptote. So you try one. In your you try one, I don't follow the format here. It's shorter. Okay. Just follow the question on you try. Okay. Don't follow the question on the. So. You try Moodle. It's very clear. I give you everything. Just answer the question. That's all. All right. So here is to summarize the arrow notation. I copy it from the book. Just add it, insert it in here. That's how they say x approaches A from the left, x approaches A from the right. Now, how do I find my horizontal asymptote without looking at the graph? Well, there's a way to do this. To find the horizontal asymptote, you're going to look at the highest. You're going to look at the leading term of the numerator and the leading term of the denominator, and then you divide them. Right. So basically, the rest is insignificant, and I'll tell you why. If you look at this example right here, look at the example right there. Don't write down. I'm going to divide everybody by x squared. Why x squared? Because that's the highest power, right? So 2x squared divided by x squared, that's just 2. Negative 4x squared divided by x squared is negative 4 over x. And then 5 divided by x squared is 5 over x squared. Right? And then I do the same thing in the denominator. Now, what happened? Well, I have the 2 and the 1 here because the x squared cancel. However, why does it become 0? Why negative 4 over x becomes 0? Well, because when x approaches infinity, 4 divided by infinity is practically 0, right? So that's why I said we only care about the leading term of the numerator and the denominator. The rest is insignificant because they're gonna vanish. Right? They'll vanish to 0. So in this case, your horizontal asymptote is y equals 2. Once you found the horizontal asymptote, you're gonna determine whether the graph gonna cross it or not. How do I do that? You're gonna set the original function equal to the horizontal asymptote that you found, right? And then solve for x. In this case, it turned out to be false, so that means you don't have horizontal asymptote. But for example, if you say x equal 2, then that means your graph cross the horizontal asymptote at what? At 2, 2. 2 for x and 2 for y. Let's take a look at example B. Maybe you understand it better. So my first step will be finding the horizontal asymptote. I'm going to take the leading term of the numerator, which is 4x here, divided by the leading term of the denominator, which is x squared. If I reduce, that will be 4 over x, yes. But when x approaches infinity, what happened? What's 4 divided by infinity equal? Yeah, 0. By the way, there's the Trip to Infinity show on Netflix. It's pretty cool. Have you guys watched that? You watched it? I like it. It's not too okay. There's certain part that maybe a little bit too much, a little bit above your knowledge, but most of it you can understand. Infinity is cool. We know how to use it, but we don't understand it. It's kind of weird. Did you know that the peptol that you guys use for your digestion, we don't know how it works? We know that it works, but we don't know how. It's kind of weird, isn't it? All right. Once you found the horizontal asymptote, which is here, is y equals 0. Right, that's your y. Then next step, you're gonna determine whether if the graph crossed the HA. Determine whether graph crossed HA. We're gonna use the original function and set it equal to the HA, which is 0 here. So 4x plus 5 over x squared minus 2x plus 1 equal to 0. What is my LCD here? X squared minus 2x plus 1. Right. So what you're going to do is you're going to multiply both sides by x squared minus 2x plus 1 over 1. I like to write like that. And then you distribute that. If we distribute that to the left-hand side, it's canceled. This is what we want, right? If it doesn't cancel, then something wrong. And then if you distribute it to the right-hand side, 0 times anything is still 0. Basically, from now on, when you have one fraction on the left-hand side and then 0 on the right-hand side, you automatically set the numerator equal to 0, okay? Equal to 0. Subtract 5 both sides, I have 4x equal negative 5, and then x equal negative 5 over 4. It's going to be a point when the graph crosses the edge A. You only have x value. What is my y value? 0, right? 0. So some people, if you don't believe it, you can put negative 5, 4 into the function and give you 0 back. Okay? Let me show you how it looks on decimals. So right there, that's my function. I forgot to, I can do negative 5 divided by 4, comma 0. Right there. I don't know. Right there, that's your, oh, I'm sorry, this is the wrong one. I'm sorry. I don't know which, they are 3.7, so function with, it was the right one? Graph, oh, okay. No, this one, yeah, all right. Anyway, that's the graph of it. And that part right there, negative 5/4 is the same thing as negative 1.25. Do you have any questions? I want to insert something. This is the one I want. Yep, that's the one I want. Okay, so let's talk about the scenario you're gonna see on the function. So what you see earlier is where the degree of the numerator is less than the degree of the denominator, right? When it's like that, when you see something like that, the horizontal asymptote is 0. And it's the same thing they say right here on the note. When the degree of the numerator equal to the degree of the denominator, like in example 3a, degree of the numerator equal to degree of the denominator, then your horizontal asymptote will be the ratio of the leading coefficient. Right? When I say ratio, I mean divide, right? Leading coefficient of the top will be 2. Leading coefficient of the bottom will be 1, right? So 2/1, which is 2. can just do the thing, just divide the leading term of numerator to the denominator. So like that. They say the same thing here. The one in the middle, when the degree of numerator is greater than the degree of denominator, then you have no Hanazono asymptote. You're gonna have what is called slanked asymptote, which is next lecture. So hang in there. Why there's no Hanazono asymptote? I'll write this down. Say if I have x cubed on the top and then x squared on the bottom, say 2 and 3 here, what is it equal to? If you reduce it down, what is it equal to? Third x, right? What happened when x goes to infinity? Infinity. We cannot have y go infinity. This doesn't make any sense, right? So no Hanazono asymptote. All right, let's do this one, number 4, together one more time. My first step is to find the HA. The drill. You set the leading term of the numerator divided by the leading term of the denominator, 1/2, and that will be your Hanazono asymptote. And please write y equal 1/2. If you just give me 1/2, it doesn't make any sense. It's the whole line. It's the whole line. So that's the whole equation. And now you determine whether it crossed the graph. So what you're gonna do is you're gonna set the original problem, which is set x squared minus 3x minus 4 over 2x squared plus ax equal to the Hanazono asymptote, which is 1/2. In this case, you cannot just remove the bottom because on the right hand side is no longer 0. So you're gonna do the LCD thing. What is your LCD here? What should I multiply both side by? Everything, right? You don't wanna think about it. Just CD. Don't have to be. Doesn't have to be least CD. Everything, right? Because you want to cancel everything. So whatever you see in the denominator, multiply by that. So you don't have to think. We'll use yellow. And then you distribute that yellow thing to the left hand side. 2x squared plus ax cancel. So what's left? 2, right, times x squared minus 3x minus 4. And then you distribute that to the right hand side. The 2 cancel. So what's left is 2x squared plus ax. Let me expand the left hand side. If I subtract both sides by 2x squared, so cancel. Maybe I'll do it slowly. Cancel. So that I have negative 6x minus 8 equal ax. Add 6x or subtract ax, doesn't matter. Let's cancel. So you have negative 8 equal 14x. Divide both sides by 14. X equal negative 47. And don't stop there, right? That's your crossing point will be. So your answer, you say yes. Cross point is negative 4/7 for the x component, and then 1/2 for the y component. That's your answer. So far, so good. Pretty simple stuff. Nothing scary there. Not yet. Right, so those are easy going part. Now come to the slightly more complicated part, which is the graph. The graph of quadratic function is pretty easy. Right? All you have to do is find the vertex, the the axis symmetry, right? And then some x-intercept, y-intercept, then you connect them. A little bit more involved with the rational function because you have a numerator and denominator, right? So you're gonna take account into where can I cross, where can't I cross, where can. Right? But there's step, so don't worry, there's step. I'll walk you through example 5. Given a rational function like this, don't write it down, just watch. The first step will be factor them. Once you have in factor form, you're going to find a y-intercept and x-intercept, which is easy, right? You guys know how to do those. On the exam, if you have something like this, we'll list out the step for you so you don't forget. Next, you're going to find the equation of the vertical asymptote, which is also easy. All you have to do is set what? Is set the denominator equal to 0 and solve, right? So that's easy. And then you determine the behavior near the vertical asymptote. And how do I do that? Well, here is the table of how you're doing that. So the first row, you're gonna list out all the value of vertical asymptote. So in this case, the value will be what? 1/2 and then -2, right? And then so each of those value is gonna have its own columns because you have to do what? -2 from the left, -2 from the right, 1/2 from the left, 1/2 from the right. The second row will be test point. I suggest you pick something that near the -2 from the left or -2 from the right, near those x values. Okay, don't pick too far because that way where you get it wrong. Right? -2 from the left. Where's -2 from the left? -3, -4, right? Well, you don't want to pick -3, -4. I would suggest something closer to that. For example, -2.1. Right? Same thing with -2 from the right. Right? Don't pick -1 or don't pick 0. Pick something near it, which is -1.9. And similar to the 1/2. Once you have the test point, you're going to plug into the original function. When I say original function, I meant the one that you factor. I don't care about the value. All I care about is what? The sign. The sign. If it's negative, then it means when x approaches -2 from the left, y approaches -infinity. If it's positive, then y approaches positive infinity. And because negative infinity. Right? And forget about it for now. We'll use it later. Forget about it. If you put in too much in your head, you get confused. Once you have that done, forget about it and move on to the next step. Right? We'll come back to it when we go graph it. So we're done with the vertical asymptote part. Next, it's going to be the horizontal asymptote. Well, you know how to find the horizontal asymptote, right? You set the leading term of the numerator divided by the leading term of the denominator. Right? Once you have that, I want to know whether my graph going to cross the HA. All you have to do is you set the original function equal to what you found for the HA, right? And then you solve for X, like we did earlier. Yay, we're done. At least for the bookkeeping, right? The next step will be graph. How would you put all that information to create a graph? So maybe you guys want to, if you don't have your note, maybe you draw down real quick those. All right, my advice to you, first thing first, plot those points down. So I have x-intercept, y-intercept. So plot them first. So plot those points down first. Let's see, I have 0 and 9/2. 9/2 is the same thing as 4.5. So 4.5 is roughly here. Well, it's actually exactly there. What else I have? For the x-intercept, I have 3, 0 and negative 3, 0. So 3 and negative 3. Next step, I'm going to graph my vertical asymptote and horizontal asymptote. So do the easy thing first. So vertical asymptote is x equal half and x equal negative 2. X equal half, x equal half. I suggest you use dash line because in reality, there's no vertical asymptote, like the physical vertical asymptote on the graph. It just, the function kind of know not to go near there, but it's invisible. And then negative 2. I want to label x equal 1/2 and then x equal negative 2. And then my vertical asymptote, I'm sorry, my horizontal asymptote is y equal 1/2. And dash line. We'll see, we'll see. Maybe I'll do sort of semi-solid because I know that it might or might not cross. So far so good. Plot the easy things down first. And then plot down the point where it crossed. It crossed at negative 16/3 and 1/2. And let me tell you what negative 16/3 roughly equal to. It's roughly equal to negative 5.3. 5.5. So negative 5.3, negative 5 right there. The negative 5.3 is right here. And then of course it crosses the horizontal asymptote. So that's your cross point. So far so good. All right, now we go to the table last. That table will be your last thing. That'll be your last thing. As x approaches negative 2 from the left, negative 2 from the left, meaning I'm going like this. I'm going closer and closer to negative 2 like that, right? But never quite touch it. As x approaches negative 2 from the left, what the table say? The table say y approaches negative infinity. So as I'm approaches negative 2 from the left, I'm just gonna do a scrap graph here, okay? So do it lightly on your pencil. I'm just gonna do, I'll fix it later. I just need to know the direction of the graph, right? So just do it like that so you remember the direction. So x approaches negative 2 from the left, y goes to negative infinity. What about when x approaches negative 2 from the right? From the right, so it go closer, closer, and closer to negative 2 from the right, like that. The function shoot up to positive infinity. So again, this is my scrap. I'll do like that. And then 1/2 from the left. Function go to positive infinity. 1/2 from the left. Oopsie. Like that, right? And then 1/2 from the right, it goes to negative infinity. So like that. How do I know which one to do? Why don't I pick that part? Yeah, whenever I hear negative infinity, I pick the lower part, right? whenever I hear the positive infinity, I usually pick the upper part, right? And then we fix it later. All right, let's fix from left to right. On the left, I know it's going down, and it has to cross what? It has to cross these dots, right? So fix your graph here a bit nicer. Look like this. Let me erase that scrap one. And then let's do the right. Let's do the right. We do the middle last. Let's do the right. The right is going down, and it had to cross this, but it doesn't cross the blue one. Right? So that means my graph look like that. And what about the middle one? The middle one, I know that it has to cross that y intercept there, but it does not move anything beyond the blue line. So it's gonna be like a parabola, right? Bounce. Let me erase that. So it's kind of like that. Is in math, at least for your level, if you see something hard, break it down into smaller parts and do one step at a time. Plus, you got partial credit. You get undergrads. You live on partial credit.
Yes. Look like the vertex or the middle graph. Like, how would you know where to put the like where it goes up, like the vertex? How would you know where to put it?
What do you mean vertex?
This part, the middle.
Oh. So remember, as x approaches -2 from the right, it go to positive infinity. As x approaches 1/2 from the left, it also go to positive infinity. Right. So my scrap graph was have two arrow going up like that, right? But I know that I cannot cross the blue one. So I go up at 2n, but at the bottom, there's no way I can go except going back up. Yeah. I'll do one, we do one more, and then maybe you feel better about this. Two more, and we'll be done. All right, so for the first step is we factor. Right? The first thing first, you factor. So factor that one. Can someone factor this one for me? I'll be very helpful and I'll factor the bottom. You guys factor the top. That will be well, that's x and x, right? Two number multiply to -4 and add to -3. Yeah, -4 and +1. Now the y-intercept, that's easy, right? The y-intercept is easiest when you look at the original function. You can look at the factors you want, but it's just easier if you look at the original function. Y-intercept when x equals 0. When x equals 0, what happens to the function? Then y is negative. And what happened to y? Undefined, right? Undefined. When x 0 in the bottom is 0, so you say y equal undefined. It's the same thing you say there's no y-intercept. No y-intercept. Be imaginary number, but we're talking about real axes here. So to find the x-intercept, you said y equals 0, and then you solve. I use a factor one, so because I don't want to factor again. Like I said, when you set something equal to 0, it only works if on the left-hand side is one fraction. In this case, it's the same thing if the denominator equals to 0. makes sense, right? If the left hand side is equal to 0, the only way it's equal to 0 is that the top equals 0, right? The bottom can't. So this implies x equal -1 and x equal 4, -1, 0, and 4, 0. Those are easy things, don't mess it up. Vertical asymptote. What is my vertical asymptote? What? Yeah, you said the denominator equals 0, right? So you said each of the factors. So I said 2x equals 0, and x plus 4 equals 0, and then I solve for x. 2x equals 0, 2 cannot be equal to 0, so x gotta be 0. Okay, so x equals 0, and x equals -4. That'll be your VA. Determine the behavior near the vertical asymptote. So what you do is you list them down, right? So I have 2 vertical asymptotes. I'm gonna have 4 values because each of them you're gonna go from the left and go from the right. So let's do -4 first, because it's smaller. So I'm doing -4 from the left, -4 from the right, 0 from the left, 0 from the right. Can someone pick me a test point for -4 from the left? Yeah, -4.1, something small, right? So -4.1, and then -4 from the right. Someone else? Hmm? Yeah, -2.9, very good. 0 from the left, I would say -0.9. And then 0 from the right is 0.1. And then you plug into, I recommend you use the factor one. It's easier. You can use the original one. There's nothing wrong with it. It's just harder. Plug in the yellow part, the yellow values to the function. So -1.4. -1.4 plus 1 is negative, right? I don't care about the value. All I care is the sign. So it's negative. -4.1 minus 4 is negative. Negative, when you plug in for x, negative. So positive overall. Right? What does that mean? That means y approaches positive infinity. Right? And then you do same thing for the rest. I'm walk around and see how you do for the rest. My Zoomer, do you guys have any question? I know you awfully quiet, and I don't want to let you behind. Uh, I'm sorry, it should be negative 0.1. But like 0 from the left. It's okay, negative 0.9 is not wrong, just a little bit further than I'm comfortable with. So maybe, I don't think it's changed much because it's not like a negative 3 or something. Let's do that. Anybody got the table finished? All right, negative 3.9. Negative, right? Negative, negative, so that's positive on the top. Negative, positive, right? So positive and negative is negative. Negative 0.1, positive, negative, so the negative on the top. Negative, positive, so negative on the bottom. Negative, negative become positive. 0.1, positive, negative, so negative, positive, positive, so positive on the bottom together is negative. Negative infinity, positive infinity, negative infinity. You get used to it once you do a lot of. Take time. Sorry. Next, we're gonna find the equation of the horizontal asymptote. Leading term of the numerator divided by leading. I thought I'm sharing. It say I'm sharing. Again. Anyone got the horizontal asymptote yet? Yeah, the 1/2, right? So x squared divided by 2x squared. Equal 1/2, that would be your y. And the next step, you're gonna set the whole function, the original function, which is x squared minus 3x minus 4 divided by 2x squared plus 8x equal to 1/2. I think we did this before, didn't we? Do deja vu. Yes, we did. We did. All the way up here. Right here, this one. 4/8. We did it. So negative 4/7. I don't want to do it again. So I'm just gonna say negative 4/7. And then 1/2. And I'll tell you what's negative 4/7 equal. It's roughly equal to negative 0.6. Negative 0.57 something. All right, you done all the bookkeeping. Now you plot them in the graph. Plot the easy one first. The table will your last. No y-intercept, but we have x-intercept. So negative 1 and 4. And now your vertical asymptote. 0 and negative. X equals 0, x equals negative 4. X equals 0 is the y-axis. -4 or 4? -4. The horizontal asymptote is y equal 1/2. And the cross point is -0.6 and 1/2. -0.6. -0.6. Right there. One. Yeah. Yeah, that's the point right there. All right, now it's kind of the harder part. Not too hard. Just slowly, one step at a time. As x approaches -4 from the left, what happened? -4 from the left is go to positive infinity. Right. So again, do scrap one, just to know the direction of the graph. -4 from the right, it goes to negative infinity. I know not to put it here. It's negative infinity. I usually look at the bottom. And x approaches 0 from the left, it goes to positive infinity. 0 from the right, negative infinity. Let's go from left to right. On the left, my left quadrant, there's no crossing. So pretty straightforward, right? Just kind of hovering your graph around the red or blue boundary. And you erase the scrap one. What about the right? I don't cross the blue line, but I do have to go through the x-intercept, right? And then going down, when it approach near the vertical asymptote. What I don't see is this. Please don't do this. Don't write it down. Maybe you can't see it very well. Don't write it like that, okay? Don't curve it down. Because your function is gonna hovering near y equal 1/2, right? Just kind of flat around there. If anything, it's kind of increasing a little bit, right? It should not curve down, indicating going down, which is not. It tries to approach 1/2. And last one, the middle part. How do you think I'm gonna graph it? What does it look like? What does the graph look like? Does it look like a parabola or the cube? Cube, right? Because it has to cross the two dots there, and it go from, if you go from left to right, that's the railroad track. Right. Go like that. Cube. Let me show you what it looks like on decimals. Let me mute that. So that's all. Yes, that's our problem, right? Is it our problem? Yes. Well, how come I must have not forgot to save it. X equal -4. Right there. And then x equals 0. Right there. Right, so it's your graph. So we do the right thing. Right? One more and then we'll call it a day. Please practice on that. We're gonna do number 9. Oh no, we do number 10. We do number 10. So far, you are given a function and then you ask to graph. Now reverse engineering. I'm gonna give you a bunch of information. You give me the function. You're gonna find the function. The x-intercept, let me write down here. My x-intercept is 4, 0 and -3, 0. This implied that is your numerator. Right? Your x-intercept is your numerator, your solution. Is your numerator. So this implies what? If I were to write this, it would be what? X equal 4, and then x equal -3. If you move everything to the left, it's kind of like we did in the polynomial. X minus 4 equals 0. And then x plus 3 equals 0. And then you put them together. So x plus 4, x minus 4, and then x plus 3. Circle just a little bit so I remember where to look. So that's my numerator. The next line is say the horizontal asymptote is equal to 2. What does it tell you? What does it tell you in terms of the degree of the numerator and denominator? It's the same, right? That's why you have it like that. If it equals 0, then the numerator is less than the denominator. So you say because the HA, which is y equal 2, this imply the degree of the numerator is equal to the degree of the denominator. So on the top you have x squared, on the bottom you should have x squared too. Right? How do I find the denominator? That'll be the next line, right? That's the vertical asymptote. That's your hint for the numerator. Like, remember we said equal to 0 to solve for vertical asymptote. My VA is x equal -6 and x equal 1. If you add 6 both sides, I have x plus 6 equals 0, and then x minus 1 equals 0. Combined together, I have x plus 6 times x minus 1. Almost there. Now I can confidently write them together. I'm going to call my function g of x, and I have the top, I have x minus 4 times x plus 3. And the bottom, I have x plus 6 times x minus 1. What am I missing? How do I know it's right? I don't. So x doesn't have to have a coefficient of 1, right? So I'm going to call it a here because I don't know what it is. And we'll try to solve for a. So that little a right there, we use black. That little a right there is a no. How do I solve for a? You know how to do this. You did it on your exam. Huh? Yeah, the way that's right, use that point. It must pass in through the function, so it's the solution. The y-intercept, or whatever they give you, in this case, the y-intercept, 0, 4. That's my x, that's my y. And then you plug it in. So 4 equal a times what? -4, +3, and then 6, and then -1. So 4 equal -12 divided by -6 is +2, right? So 2a, a equal 2. And I don't have any place. So my final answer is g of x equal to, leave it in factor form. You don't have to expand it. If nothing else, we finished for the lecture today. Have a good one, and I'll see you again on Wednesday. And I'll have the copies for you. I'm sure they fixed it now. Bye, Zoomer.